Greetings, bass enthusiasts and enablers. Today we rebuild the legendary Jack Daniels bass. This is a custom bass from Palace Guitars, and it's a replica of Michael Anthony's from Van Halen. But due to some design issues of the bass, I haven't been able to thump and pluck this John since last July. And it looks beautiful, but all of this hardware on the bridge and on the headstock, as you can see there, that was all hardware that was made in China. So it's very low quality. And I'll show you what's wrong with it. On this bridge, the strings will hook into these tuning claws behind the saddles. And these tuning nubs pull the tuning claws to tighten the strings. The issue is that with enough string tension on these tuning claws right there, the tension will pull so hard on the screw that the hole inside the claw strips and the knob spins all william-nilliam. There's no way to really properly intonate the bass because these saddles just come right out. The headstock is another disaster that is rather hard to explain. This is a really poor design. These blocks hold down the strings, which is fine. And you put each string into those tiny little holes right there. And then you'll use these set screws to tighten it down. But the issue is you have to cut the string at the perfect length so that it measures almost perfectly from this hole to their tuning claw. And then oftentimes the string would break from burrs in the hole. So I ordered a part with a different design. And I think it's going to fit in pretty much perfectly. And then I ordered another bridge that's not this brand, because Palace Guitars has sent me a replacement of this after the first one stripped out as mentioned. And this new one's stripped again, so it's useless. But I really want to get this thing working because it's beautiful, so let's get after it. Another issue with this bass is that the pickups don't really work that well. They don't pick up signal from G and D strings very well. It's not nearly as loud as the output for the E and A strings, so I bought some new ones. And we're going to swap those out too. This is the new headstock piece. And as you can see, instead of the string having to go down in a hole, each string actually goes all the way through, and you can snip it as needed and secure each string with 2 of these set screws per string. I'm going to have to drill some new holes into the headstock to fit this. These 4 large holes in this headstock piece are what secure the actual piece to the neck. Alright, so we got the new headstock piece installed. It's looking good. Alright, so here's the new bridge. And as many of you are probably wondering, how can this new bridge be compatible? But the only thing that really matters here is that these saddle points are 34 inches from the nut, which is at the topmost fret. This is because the scale length of the bass is 34 inches, which means the notes will only ring out right if we place the bridge right. You know, we can fine-tune it, but, you know, we want it to be as close as we can manage. I can't place the bridge in the right spot due to its geometry. But luckily we have the technology. I had to 3D print this little mounting bracket, and so that'll just go on here as such. And then this will sit on top of it. So now the bridge can be mounted in the right location to achieve intonation, and there's clearance to turn the knobs. Without the bracket, the knobs would prevent the bridge from sitting flush. Hold on, I got this John upside down, dadgummit. Now this is the right way. And this little arm is what tells me the distance. I needed to push this up in comparison with where the old bridge was so that it gets intonated correctly. So as you can see here, or maybe not, 34 inches from the nut of the bass down to the saddles. Looks about right. So we know that this is the correct placement. And if worse comes to worse, we can fine-tune the intonation using the mobility of the saddles on this bridge, which is an advantage because the old bridge didn't have a way to adjust the intonation. Okay, so if you see here, before I put the bridge on, and they have this little wire sticking out here. That's the ground wire. We want the bridge to be grounded to the electronics cavity, so since the fridge is metal, that would normally be fine, because that wire would be touching the bridge. But since I'm going to have this plastic mounting bracket in between, I'm going to take some copper tape and wrap it. And this wire should end up touching this, which will have the conductive tape on it. And I went ahead and sanded down a little bit of this paint. So we have exposed metal, and all of it should be connected. But she'll check it with a multimeter once we're done. All right, so we got this plate with a piece of copper. Like so, and just for good measure, I'm actually going to loop this ground cable through one of these holes. It's just so that I know. Of what the asterisk is going on here. Like that. So let's check conductivity. Watch, some numbers has to pop up there. We're good. So I sanded some of this off, because this paint is not conductive. Put it on. And then I'll check for conductivity. We're good. All right, so this is the new bridge mounted up. Looks beautiful. Now we are removing the pickups. Make sure you keep track of the wiring configuration to make the job easier. All right, so we took the pickups out, and if you know me, I like covering stuff in copper tape. This is how we make a Faraday cage. And hopefully it will ward off stray frequencies that's trying to come in from lights or radios or whatever. It'll hopefully reduce humming. I have found that this technique only works half the time. The goal is to cover as much of the cavities in conductive tape. Then we connect the tape to the GND. Ideally, this will send stray RF frequency to GND. I have only got this to work perfectly on one bass. I didn't shield the entire space, since the hot wire may touch that area. If your hot wire touches grounded shielding, you will short circuit the base. I'm now putting a screw into the pickup cavity. I will solder a wire from the screw to another cavity. This ensures all the shielding is connected and grounded.